Welcome friends. The total electromagnetic spectrum of yesterday's discussion is consisting of different parts of energy portions: cosmic rays, gamma rays, X-rays, UV rays, visible portion IR, infrared radiation, followed by microwave radiation as well as the radio waves. In these, cosmic rays are having highest energy and also associated with the highest frequency, highest wave number and the least wavelength. Similarly, from cosmic rays to gamma to X-ray towards the IR rays, the energy decreases, frequency decreases, wave number decreases, wavelength is goes on increasing. And the small part of this electromagnetic radiation is visible part. Generally, we will feel it as light. Whereas this visible portion is also consisting of light of 7 colors, that is violet color, indigo color, blue color, green color, yellow color, orange color as well as the red color. In this, out of this light of 7 colors, the violet color is having highest wave, highest energy, highest frequency, highest wave number and the least wavelength. Similarly, from the color of violet to the red, the energy decreases, wavelength decreases, wave number decreases, but wavelength is goes on increasing. That is, energy is minimum, frequency is minimum, wave number is minimum, wavelength is maximum. Wavelength is maximum. Such kind of trend is maintained in the light of 7 colors. We, on behalf of different energies, a particular energy is considered as one particular part of electromagnetic radiation. Thus, it is higher energy, the most highest energy, cosmic. The second highest energy, gamma rays, and the least energy is infrared radiation, followed by the microwave radiation, followed by the radio waves. Like this, it is segregated. Moseless experiment as well as atomic number. From the cathode rays experiment, different investigations are under progress, and in these investigations, instead of the anode metal, here different varieties of materials are used as anode, that is anticathode. As a result, Röntgen identified that when high energy electrons are discharged, collide with the anode, penetrating radiations are produced. These penetrating radiations are named as X-rays. Whereas mostly investigated the spectrum of the penetrating radiation obtained from the different varieties of anti-cathodes. So this is cathode and this anode is said to be the anti-cathode. In the discharge tube of high energy, when the electrons of high energy radiation fell over the anti-cathode, penetrating nature containing radiations are emitted. By keeping different varieties of the materials there, mostly investigated the spectrum of the outcoming penetrating radiation. He investigated the spectrum of the penetrating radiation of elements from aluminium to iron. Almost some 38 elements related X-ray spectrum is investigated by the Moseley. Thereby, he came for the conclusion that the frequency of the radiation coming out of the anti-cathode experiment is proportional with the Z. Z is atomic number. And proper arranging the things, it is proportional with the Z minus B, and it will becomes equal to square root of frequency will becomes equal to some proportionality constant A into Z atomic number minus B. B is said to be the shielding constant. That is the properties. Generally, the properties are coming from the outer electrons. So therefore, the X-rays are alpha X-rays, that is are coming from the outer electron replacement. So therefore, the properties of the atoms of the elements are periodic functions of the atomic number. Thus, we came to know the modern periodic law from this experimental results that properties of the atoms of the elements are periodic functions of the atomic number. Here, nu is frequency, A is proportionality constant, Z is atomic number, B is shielding or the screening constant. As the atomic number increases, the frequency of the radiation emitted by the X-rays is also goes on increasing. See here atomic number is increasing, the frequency of radiation is also increasing. Thus, properties of atoms of the elements are periodic functions of the atomic number. Thus from here the modern periodic table is designed and modern periodic table laws came into existence. Here the screening constant value is characteristic of the atom of the element and it is calculatable. After substituting the screening constant value with a proper proportionality constant, it was found that square root of frequency is proportional with the Z. As Z increases, frequency increases. Z decreases, frequency decreases. Implies what? All properties of atoms of elements are periodic functions of atomic number. Next is Max Planck's quantum theory of electromagnetic radiation. It reveals some other information related to the electromagnetic radiation. A metal sphere, hollow metal sphere which is not having anything at the interior, having hole at the wall, coated inside with the platinum black is acting as near black body. Black body is such a substance that it can take almost all the entire radiation felt on it and it can re-emit the total observed radiation. Such a material is said to be the perfect black body, but in nature we can't find any kind of perfect black body. So a hollow metal sphere having a hole at the wall and coated inside with the platinum black is acting as near black body because it can take up almost all the radiation felt on it and it can re-emit most of the radiation that it is observed. Hence it is said to be the near black body, and for our experimental science we can take it as a black body. And Planck did the investigations on the black body radiation, thereby he revealed the secrets related to the light, and these are like this. The visible glow that the solid objects gives up when heated are examples for the black body radiation. The best examples are the reddish glow from the heating element in an electrical stove. Similarly, the white light emitted by the hot filament present in the bulb are examples for the black body radiation. Whereas the hollow metal sphere having hole at the wall coated inside with the platinum black, if it is exposed to the highest energy of radiation, then energy is taken by the electromagnetic radiation. Almost all the 100% of energy absorption is taken place. Then after it is having higher energy, that particular black body is said to be the excited situation of the black body. It can sustain for some time, then after it will releases all varieties of electromagnetic radiations that it take up. So these of all electromagnetic radiations will be coming out. Thus black body is acting as perfect absorber of the electromagnetic radiation, that is energy, and also perfect emitter of the energy, perfect emitter of the electromagnetic radiation. Planck investigated the radiations coming from the black body at various temperatures and he gave a graphical information related to the intensity of the waves coming of the black body at different temperatures. Thereby he came for the conclusion, and that conclusion is known as Planck's quantum theory of the electromagnetic radiation. The investigations results into the form of a graph by the Max Planck of the black body radiation in such a way that intensity versus wavelength, if the graphical information is plotted at various temperatures. See here, the wavelength is increasing on the x-axis, intensity is increasing on the y-axis, whereas here different temperatures like T1, T2, T3 temperatures are there. Compared to T1, T2 is greater, compared to T2, T3 is greater. At T1 temperature, intensity in the beginning increases from the lower wavelength to the higher wavelength, then after it is decreasing. The same repetition is present at T2 and at T3 temperatures. But there is a logical relation between the intensities at various temperatures. At high temperature, what happens is the maximum intensity is shifting towards the minimum wavelength. Thus, as temperature increases, then the minimum wavelength, that is high energy associated waves number is goes on increasing. At lower temperature, T1 temperature, The maximum intensity is associated with the wavelength which is of nearly higher wavelength. Whereas at intermediate temperature, the intensity is shifted towards the minimum wavelength. Still, as temperature goes on increasing, then the maximum waves, those are liberated from the black body, are of minimum wavelength containing waves are going to be radiated from the black body. This is the information given from the graphical portion, which is plotted against the intensity versus wavelength by the Max Planck of the black body radiation. Then the conclusions related to this particular graphical information of the black body radiations are like this. As the observation of the radiation coming from the black body, the drawn graph reveals the information as temperature increases, the intensity of the emerging radiation from the black body is shifted towards the minimum wavelength. Implies what? At higher temperature, the minimum wavelength containing waves emitted by the black body are more. Whereas at lower temperature, the relatively maximum wavelength containing waves coming out from the black body are more in number. That is, number of waves are not constant. Number of waves are varying. Within the same time, the number of waves at lower temperature, number of waves at higher temperature are different, implies waves are not in continuation. Waves are discontinuous. There exists some gap between wave and wave. That is, wave emission takes place in the form of discontinuous manner, not in continuous manner. This is the conclusion given by the Planck related to the electromagnetic radiation from the black body experiments. Whereas conclusion, emission of radiation is due to vibrations of the charged particles. Radiation emitted discontinuously, not in the form of continuous manner. Whereas every wave is associated with energy. That energy of the wave is proportional to its frequency, that is nu. Whereas if I remove the proportionality constant with the h, that h is said to be the Planck's constant, that h times of nu will gives the energy associated with the wave. So energy associated with the single wave will becomes equal to h into nu. H is Planck's constant. Its value is 6.627 10 power minus 27 every second, or in SI system that will becomes equal to 6.627 10 power minus 34 joule second. This is the conclusions given by the Max Planck related to the black body radiation of the graphical information. Here, have a look related to the black body radiation. At some temperature condition, a particular wave is having maximum intensity. It is possible if it is continuous. Suppose let us see. The wave of a particular wavelength at some particular temperature is continuous. One wave, second wave, third wave, four waves are liberated within a particular time gap. Whereas under some other temperature conditions within the same time gap, intensity of wave is little. Implies what? Some less number of waves are liberated. Here 4 waves are liberated. Here 3 waves are liberated. At some other temperature, might intensity is still less. That is, 2 waves may be liberated. Implies what? Waves are, it is continuous mode for your vision. It is discontinuous mode. So therefore, waves never be continuous. Waves always propagates in the discontinuous manner. There exists some empty space. So therefore, every particular wave is having its energy equal to its corresponding h nu. The total energy liberated will becomes equal to E is equal to n times of h into nu. N is number of waves. Every h nu is said to be the perfect. A particular wave is associated with particular amount of energy, and this is said to be the quanta. That is, the energy liberated from a radiation, energy propagated from the radiation in the form of radiation of a particular wave is multiple times of quantas. 1 quanta, 2 quanta, 3 quanta. N number of quantas will be present, but it is not the submultiples of quantas. Thus, a particular waves related emission or absorption takes place as the multiple times of its corresponding h nus. Every h nu is said to be the energy pocket, the minimum currency. The minimum energy pocket is said to be the quanta. That is, in multiples of quantas, energy absorption and energy emission of radiation of a particular wavelength takes place, but not in the form of submultiples. This is said to be the Planck's quantum theory. Whereas here Avogadro number of 6.023 into 10 raised to 23 number of waves related energy is said to be the Einstein, and one particular wave related energy is said to be the one quanta. So therefore there are another technical term, that is if n is equal to 1, that is said to be quanta, whereas if n is equal to Avogadro number, then it is said to be the Einstein. So now you are asked to calculate the energy of an electromagnetic radiation of wavelength 400 nanometers. Lambda of 400 nanometers is given. You are asked to calculate the quanta, and also you are asked to calculate Einstein. Calculate energy of the electromagnetic radiation of 400 nanometers of quanta as well as Einstein value. That is, the total amount of energy emitted or absorbed by a body will be some whole number multiples of quantum, that is E is equal to n into h into nu. N is an integer, that is 1, 2, 3, 4, etc. That is, a body either can emit or absorbs the radiation in multiples of h nu, integral multiples of h nu, but not the submultiples of h nu is said to be the quantization of electromagnetic radiation proposed by the Max Planck from the black body radiation. The question for you is, calculate the quanta and Einstein of wavelength 3200 Armstrong units and 7600 Armstrong units in all units of energy measures like electron volts, ergs, joules, calories as well as kilocalories. Photoelectric effect. Metals are easy hold of the electrons, easily loses electrons, and these are acting as good reducing agents. There is a special theory to explain the features and the characteristic properties of the metals. A theory is known as metallic theory or metallic bond. In this, what happens is, metal kernel is present in the sea of electrons. Electrons are freely moving from one location to other location. That's what these are acting as good conductors of electricity. Electrons and the other electrons are interacted with some little attractions, and the electrons and kernels are attracted with some weak forces of interactions. Whereas when energy of sufficient strength felt over the metal surfaces, the interactions of electrons with the others, interactions of electron with the kernel are easy interactions, that is less strength interactions. These of all will be broken. As a result, what happens is, electron will become free of interactions and it will be in motion. It is having its with some kinetic energy, it will be coming out of the atom. That is, when energy of sufficient strength felt over the metal surface, then the electrons will become free of its attractions with the other constituents of the metal. For this particular part, some part of energy will be consumed, whereas the remaining amount of energy present in the radiation will be transferred to the ejected electron in the form of its kinetic energy. This particular theory is said to be the photoelectric effect. Photon, that is light particle of sufficient energy, when felt over the metal surface, then metal which is holding of weak interactions of the electron with the others will be broken. For this purpose, some amount of energy will be consumed, and the remaining amount of energy is transferred to the electron in the form of its kinetic energy, is said to be the photoelectric effect. Let us see here. This is photon in the form of wave. Let us we are considering that is having an energy of EA plus EB. Whereas in order to make free the electron from the corresponding constituents attractions with the other substituents present in the metal, some amount of energy is consumed for this. Let us consider EA portion of amount of energy is consumed for this attraction purpose. Then the remaining amount of energy associated with the moving electron, that is kinetic energy associated with the moving electron, will becomes equal to what? EB. This particular EA amount of energy is consumed to make the electron free, and remaining amount of energy is present in the form of its kinetic energy. Here also the law of conservation of energy is valid. Out of total energy of sufficiently excess, some amount of energy is utilized to make the electron free, and the remaining amount of energy is present in the form of kinetic energy of the electron is said to be the photoelectric effect. See here, when the photon or a beam of electromagnetic radiation of sufficient energy of Ea plus Eb when felt over the metal surface, the attractions of electron with the other constituents are broken. For this purpose, some amount of energy is consumed and the remaining amount of energy is present in the form of kinetic energy of the electron. That is, Ea is consumed over here, the remaining Eb is present in the form of kinetic energy of the coming out electron, that is said to be the photoelectron. Thus here, the total energy of radiation will becomes equal to what? Ea plus Eb. Out of this Ea plus Eb, some portion of energy Ea is utilized to make the electron free from the other metallic interactions. That function is said to be the work function, whereas remaining amount of energy is present in the form of kinetic energy, and mathematically this can be given as E, energy of the electromagnetic incident radiation will becomes equal to E0 plus kinetic energy. E0 is said to be the work function energy to make to start the work, that is to make the electron free. The minimum amount of energy required is said to be the work function, whereas for that work function energy followed by the remaining amount of incident is present in the form of kinetic energy Ke, which will becomes equal to half mv square. In terms of wave related information, if I express this one in terms of wave parameters, h nu will becomes equal to total energy of incident will becomes equal to h nu 0, that is minimum amount of incident radiation required to make the electron free plus the remaining amount of energy is present in the form of kinetic energy. Kinetic energy of a mass containing velocity containing object will becomes equal to half mv square, whereas hc by lambda will becomes equal to hc by lambda 0 plus half mv square. This can be also energy. We can express this one in terms of h nu hc by lambda also. Thus, the minimum amount of energy required to make the electron free from the other interactions of the metal is said to be the work function, whereas the remaining amount of energy is present in the form of kinetic energy, that is h nu will becomes equal to h nu 0 plus half mv square. Otherwise, this can be also expressible in terms of what? H nu, whereas that is remaining amount of energy. Threshold energy or the work function, the minimum amount of energy required to make the electron free from the metallic interactions to make it as photoelectron. The required amount of energy is said to be the threshold energy, whereas threshold energy is also known as work function, that is minimum amount of energy E0 will becomes equal to h nu 0, can also becomes equal to hc by lambda 0 hc into nu bar 0, whereas here nu 0 stands for threshold frequency, lambda 0 stands for threshold wavelength, whereas nu bar 0 stands for threshold wave number. As the attractions are more, required frequency is more, required wave number is more, required wavelength is less, and these of all are minimum and the required to start of the process. Hence, these of all are said to be the threshold values. Hence, it is threshold frequency, threshold wavelength, threshold wave number, threshold energy, which is also known as work function. Everything are same but expressible either of energy form or of frequency form or of wavelength form or of wave number in form. The kinetic energy of photoelectron, which is coming out of the photoelectric effect, can be given by kinetic energy of photoelectron h nu, total energy of incident radiation, E is of energy minimum required for the making of the photoelectron free, and the kinetic energy of the photoelectron. Kinetic energy will becomes equal to h nu minus h nu 0. H nu is equal to hc by lambda. This is hc by lambda 0, that is hc of 1 by lambda minus 1 by lambda 0 is the equation used for the calculation of kinetic energy associated with the photoelectron. Graphs related to the photoelectric effect: kinetic energy versus potential, kinetic energy versus frequency of the electromagnetic radiation applied. If I apply more frequency containing electromagnetic radiation, that is frequency is increasing on x-axis, kinetic energy is increasing on y-axis, some amount of energy is utilized to make the electron free. That particular energy, that particular frequency is said to be the work function related frequency. Whereas photoelectric effect if starts, then the remaining amount of frequency will be converted into the frequency related energy is converted into kinetic energy. As frequency increases, kinetic energy associated with the photoelectron as well as the current associated with the photoelectron is also goes on increasing. The next graph is kinetic energy versus intensity of the same radiation. Intensity stands for number of waves. As number of waves increases, electrons increases, but not the electron velocity. Kinetic energy remains same, though you may use maximum intensity, minimum intensity of working kinetic photoelectric effect. Kinetic energy of the all electrons remains same, but as electrons increases, then what happens? The charge carrier number increases, kinetic energy, that is photo current also increases. And the next is number of photoelectrons versus intensity. For a working photoelectric system, as the intensity increases implies number of photons increases, number of waves increases, so therefore number of electrons liberated also increases, so therefore number of photoelectrons also goes on increasing. Is another technical word in the photoelectric effect, that is stopping potential. The potential required to stop the ejection of electron from the metal surface when an incident beam of energy is greater than the work potential of the metal is directed on it is said to be the stopping potential. That is, when a photoelectron of highest energy is incidented over the metal surface, it leads to the photoelectric effect. Whereas to stop the ejection of this photoelectric effect, the negative potential applied to not to release the electron free is said to be the stopping potential. It will becomes equal to two things. One is it includes the work function, and secondly it includes the energy of the electromagnetic radiation incident on it. Thus the potential, negative potential, opposite potential required to stop the ejection of electron from the metal surface when a incident beam of energy is greater than the work function of the potential is directed on its surface is said to be the stopping potential. Next is working conditions of photoelectric effect. When incident beam is having lesser energy than the work function, there is no free electron, there is no photoelectric effect. Whereas if its energy is greater than the photoelectric effect, that is work function, that is electron becomes free, then it is ready for the photoelectric effect. When incident beam energy is equal to work function, then electron will become free, but it doesn't offer any kind of current. Photoelectric effect is initiated, electron become free, but it is not having any kinetic energy, not having a carrier ability, hence not acting as a carrier of the charge. Whereas when incident beam is having higher energy than the required, then the remaining amount of energy is present in the form of kinetic energy of the electron. Thus it is acting as the current carrier. Thus the working condition must be the incident beam is having higher energy than the working potential, otherwise the work function related to the metal. Work function is characteristic property of the metal. It depends on the interaction strength. Some metals are having more interaction strength, maximum work function, that is they requires higher energy to break the interactions, hence they are having maximum work function, hence the liberated kinetic energy of the electron might be less. Thus work function is characteristic property of the metal. You may have questions on behalf of photoelectric effect to calculate the total energy of the beam, electromagnetic radiation, to calculate the work function, to calculate the kinetic energy associated with the electron, or the energy in terms of frequency, wave number, wavelength. Similarly, the velocity associated with the electron. Such kind of many different varieties of questions can be asked. Otherwise, the kinetic energy of the electron in terms of frequency, wavelength as well as the wave number of the electromagnetic radiation. Thus, this particular photoelectric effect reveals that light, that is electromagnetic radiation, is having particle nature. If it is having particle nature, then only some portion of this particle energy is transferred to make the electron free. This is not the property of the wave. Photoelectric effect is explainable if we assume that light is having, that is electromagnetic radiation is having particle nature. Thus from different theories, different assumptions are there, all are correct at their corresponding incidents. So therefore what we have to assume as a result of this photoelectric effect in association with the other properties of light are, light, that is electromagnetic radiation, not only having the wave properties, it is also associated with the particle properties. For our convenience, wherever it is required, we have to consider sometimes it as particle, sometimes it as wave. The property of dual nature of electromagnetic radiation is characteristic of matter, including microscopic particles like electrons. Thus, a wave-like as well as a particle-like radiation explains dual nature of the radiation.